Example 2. This is enthalpy of neutralization, so it's the energy released when you add an acid to a base. So in this case we're adding 50 centimeters cubed of 1 mole per decimeter cubed hydrochloric acid to 50 centimeters cubed of sodium hydroxide. They are both 1 mole per decimeter cubed in concentration. The temperature rose by positive 6.8 degrees C. Calculate the enthalpy neutralization for the reaction. Assume that the density of the solution is 1 gram per centimeter cubed. What that's telling you is that the new volume formed, in this case, is going to be 100 centimeters cubed. If the density is 1 gram per centimeter cubed, it means that for every 100 centimeters cubed, it's going to weigh the same amount in grams. Okay, so that's going to be useful for the mass of solution being heated. The specific heat capacity of the solution, okay, is the same as water, and that is C is equal to 4.18. Okay, so again, straight away, jump off equation is Q is equal to MC delta T. MC delta T. This is what we're trying to work out. Now the mass is going to be 100 grams because it's the volume here. 4.18 standard. The delta temperature, the change in temperature is 6.8 Kelvin. So let's work it out. Substitute your values in. 100 times by 4.18 times by 6.8, and we get 2842 joules of energy, and we can convert that straight away to 2.842 kilojoules. Line around there. So that's our Q value. Right, so the next thing we need to do is work out the delta H using the Q value, the negative Q over N. So now we know Q is 2.842 kilojoules. So the next thing we need to do is work out the number of moles. Now we've got two substances, so we're going to work out the number of moles of each. So the number of moles of HCl is going to be equal to MV over 1000 because it's a solution. And we're going to do exactly the same for the NaOH, again MV over 1000, and in this case they're both the same concentrations and the same volumes, and they both come out as 0.05. so by definition we always use the limiting reagent. It's a one-to-one reaction, so these are the same values, so we can use just one of these. So it's delta H is equal to the minus Q of the limiting reagent. So minus 2.842 divided by 0.05 is equal to minus 57 kilojoules per mole.